Good morning, everybody. Nice day. Nice day. Nice day. So, one of my a student I had met so many years ago. I'm all over Facebook. I have tons of people that I got on there. That's me. Sorry if I disappoint you. So, one of the few things that I don't like about Facebook. There's no dislike button. I appreciate that. I can go with that. I don't need to know someone's political agenda. Vote for this because. Okay, yeah, that's going to change my vote. So I don't really like that. One of my favorite things on Facebook, but it also at the opposite end becomes something that I don't like as much because it reminds me that I'm getting older. It's the whole birthday thing. And so, a student that I had my very first year teaching turned 37 today. I'm like, really? She's 17 still. As a teacher, it's just, I know life. Everyone progresses in age older each year, and which is great. But boy, I don't know, maybe it's going to hit me hard when I see the one where I now have a student who's now 40. It'll be coming faster than I know it. But, and then one of the things I do dislike about the birthday portion is you see somebody who has passed away, whose Facebook account is still active, and you go take a look at their page, and they have, 7,000 birthday wishes. And it's like, people not realize they died. So it's kind of a strange thing. I don't know what the proper etiquette to the whole thing is, but so let's talk about the homework from last night. Not that I had anything to do with Facebook, but so what kind of function is it? 1, 2, and 3 are all what? Quadratics. It doesn't matter if it goes upside down or opens upside or right side up. So they're all quadratics. Is everyone okay with that? All 3 of them are quadratic, so all 3 of them have a domain of what? And if you have your homework, this would be a good time for you to get it out and check it. Yes, the domain of each and every one that happens to be a quadratic will go from negative to positive infinity for the domain. Is that okay still? So then let's move down a little bit. The range is where things get a little different. The range gets a little different. So the range here, remember I'm on the elevator up and down. So this is 1, 2, 3. So it looks like from 4 to negative infinity. I could do, that's letter C. So from 4 to negative infinity would be our range there. The range here is going to go from 1, 2, 3 to where? It's going up, so that's going to infinity. What about this one? Where's the range going from? Good. So I think the range is the one that always goofs people up, but it's just a matter of practicing and going over it. So letter D, the maximum or the minimum value of the function at x. F at x means what?
Y.
So that means the same thing as y. Okay, so we're looking for the largest or the smallest y value. So what's the largest? Would it be the largest or smallest y value here? Largest. So what is it? It's 4. Is this the largest or smallest value here? And what's the value? 3. And then is it the largest or smallest value here? Which is? Good. So the maximum or minimum value go along with the range as well. E, talking about the roots. So here's a root, here's a root. So this one looks like 1, and negative 3. Roots here? No. Okay, it does not cross the x-axis, so you don't have roots. Roots here? Yes, here and here. So that's what, 3 and 5? C. Oops, 3 and 5. Cool. All right. So there. All right, roots. The equation of the axis of symmetry. The equation of the axis of symmetry, remember that is the vertical line that goes right through the center of the vertex. So letter G.
Wait, did you miss a vertex?
Oh, the vertex is ordered pair. Thank you, thank you, thank you. Okay, letter F. Vertex is ordered pair. -1, 4. Vertex here is 0, 3. Is that right?
Yeah.
Vertex here is 4, -1. And then the axis of symmetry, let's see, axis of symmetry is going to go along with that. So I get x equals -1, x equals 0, x equals 4. That's a vertical line. So the intervals where it is increasing. So from here to here, this is increasing on this one. It's increasing from here to here on this one, and increasing from here to here on this one. So the increasing is integrals where it's increasing. We're going to go from -infinity all the way up to -1, and it's a rounded bracket. It's increasing from 0 to infinity here. It's increasing from 1, 2, 3, 4. So where it's increasing, notice is a rounded bracket because you don't include that point, because as you get to that point, what happens is it becomes a horizontal line, so it's not increasing or decreasing. It's staying the same. That's the first part of the homework. Yo.
I'm confused. So I got like, one I got -infinity and 4 for intervals where it's increasing.
Okay, so the intervals of x, where f at x is increasing. So the intervals of x. So you're looking at the x component of where it's increasing. So it's going from -infinity to -1. So in the x direction, as I travel along this, and I get to here, our function at x was increasing. That's what it's asking. Good, but do you see where that, you flip-flopped it. You're correct in saying it's increasing in the y direction doing this, but what we're really doing is we want to know in the x direction when is our graph increasing. Okay. So, and that's a common error. So however you need to make that flip-flop it, okay? Can I clear? Yeah. All right, moving on down. For each graph, identify each as what kind of graph is it? No. What kind are they all? They're all exponential, right? The domain of the exponentials will go from -infinity to +infinity. So all the way right to all the way left, the graph will exist somewhere. Hello, thank you very much. Okay, does she need to be escorted?
I mean, I don't know.
You're good?
I don't think so.
Nope, all right. Perfect. You don't have to be escorted.
If she could be escorted, it would be written.
Yeah, it would have been written in something
Big deal. All right. Shh. The range. Let's get to the range. Let's talk about the range. Talking about the range of these. So the range, I am going to go from 0, start from here, and I'm going to head on up. Okay, so the range on the first one is going to go from 0, round bracket, to infinity. Why am I not having it as a square bracket? Good, it won't go through that 0, okay? It's an asymptote. It will approach it, but it won't go through it. This one, the range, same thing. Going starting here, heading on up. So that's also going from 0 to infinity. Anybody want to take a shot at what this one's doing? Yeah, there you go. It's going to go from 1 to infinity. Okay, and this happens to be our asymptote right here. Okay? Equation of the horizontal asymptote. The equation of the horizontal asymptote. So x equals 0 on this one, or y equals 0, excuse me. The horizontal asymptote on this one. Y equals 0 is on this one. Remember, it's a horizontal line, so y equals, vertical lines are x equals. And then this one is what? Y equals what? 1. Okay? Roots. Is it across the x-axis? It's across the x-axis? It's across the x-axis? Roots? None on all three. Is that all right? All right, and last one. Is it growth or decay? Growth or decay? Growth? Growth? Decay? Growth. Good deal. You guys are nailing these. Are we good? May I move on?
Yes.
Okay. Clear and think. For each graph, identify what each graph is. What's each graph? Linear. They're all linear. Linear. Yay. All right. What is the slope? The slope is the rate of change. The slope's always going to be consistent. So the slope on this first one, I can do this. I can go down 1, 2, right 1. So the slope of the first one is negative 2 over 1 because I went down, right? The slope of this one is I could go up 2 over 3. So if I go up 2 and over 3, I think that worked. And then the slope of this last one is going to be negative. And it's going to go from down 2 right 1, so negative 2 over 1. So there's the slope on all three of those. Roots. So that looks like about 1.5. That looks like about 6. That looks like about 2.5. Is that okay? And the intervals of x where it is increasing. So where is it increasing? This is not going to increase. The intervals of x where it's increasing from negative infinity to positive infinity. Okay? And the integrals where it's increasing. This is not. The two that are not, what do you notice about the slope on both?
They're both negative.
And you have both negative slopes. Okay? So a negative slope means it's not increasing. Okay? You guys all get the homework yet? Yeah, Preston.
So the roots would it be 1.5 comma 0 or would it just be like 1.5?
I would take either answer. If I had it on a multiple choice test, I would have it labeled one way or the other. I wouldn't have both listed. Is that okay? We feel good about it?
Yeah.
That was the whole thing, yes? I think?
Yeah.
Maybe? Okay. Okay. All right. If you have your workbook, cool. If you don't, I would just jot this down because this will be part of your homework. So if you have your workbook, get it open to the page with number 5, functions in context. What is it, pages? 149? Sweet. So get it to page 149. Okay. Linear, quadratic, exponential function number 5. Okay, so this is part of your homework. So if you have this worksheet, cool. If you don't have it, get it out of a sheet of paper and jot it down so you can add it to your homework for next time. So a rancher is building a rectangular corral for her horses. Okay? They must be circular. Too many corners to get stuck in. She can only afford to build 300 feet of fencing, but wants the area of the corral to be as large as possible. The graph is described in the area of the corral in terms of its width. Okay, so width is the x-axis, and the area is the y-axis. Okay, so x comma y, your x point would tell you what the area and the y would be. Few things that are strange about this. The reason why an area can be a quadratic is a quadratic is raised to the second power. That means it's in the dimension of a second dimensional object. Okay? If you have an area is also 2D. You have length and width. So that's why a parabola coincides with talking about an area. Is a parabola and a area are both talking about two-dimensional objects. Does that make sense? All right, so the graph below describes what is the vertex of this function and what does it mean in the context of the problem. So it looks like 75, comma what? What's the vertex? Is it 5625?
5625.
Mac, you're all full of excuses right now, aren't you? You can't really read it. And if I look over it, oh, good, you do have it out in front of you. All right. So what does that mean in the context of the problem? What does the x component mean? It is the maximum area of which part? Which part is the maximum area? Look at how the graph is labeled. What is the x component labeled as? Feet, and it's also in width. What is the y component? Which is in square feet, correct? Okay, so I have 75, comma 5,625. What would that mean in the context of the problem? I want to create a rectangular region. I only have 300 total linear feet of fencing, so somehow I need to make that fencing into a rectangle. So what does the 75 represent? What is the x component listed as? Width. What does 75 mean? The width of what? Right. So the width of our corral, if we have the width of our corral being 75 feet, so that means I had to use 75 feet and 75 feet, which is 150 feet, and we have 300 feet available, so that leaves us another 150 feet. So then our length would also be 75 and 75. So in this case, if we have a square corral, we would have a maximum area of what? 5,625 feet. So that's what the vertex refers to in the context of this problem. If I had the width of my rectangle being 75 feet, it would allow me to have an area of 5,625 feet, which in this case would be the maximum area that we could have enclosed with 300 feet of fencing. The point 30, 3600 is on the graph. Explain what this point means in the context of the problem. 30, 3600. What does it mean? If what? I heard it. With what? What's the width though? 30. So if I have a width, we have a width of 30. our area will be 3,600. Hey, I don't know why I have that. Is that the maximum area? No. What is our maximum area? 5,625 feet. So, is it possible that you could have a scenario where you might not be utilizing the maximum amount of fencing? Absolutely. Might you be bound by the area? Sure. You might not have enough space to have the maximum amount of area, but let's say that you did have enough space. But that's what this would mean. So this context also means the same thing over here. So that would mean if you had a width of 120, then you'd also have a width of 3,600. Okay? So, parabolas with the context of what the problem means. Look at what this versus this means, which means your width, comma, area, okay? And that'll tell you, that'll be able to utilize it. Do you think that companies could utilize this type of math? If you're a fencing company, sure. Okay? Now, I'm not talking about the guy that's going to come out and put your fence up for you, but when that guy's ordering, this kind of math is going to make sense. If you work for some construction company, absolutely this kind of math is going to work for you. Okay? So it's the logical progression. Are you necessarily going to graph a parabola to do it? No, but the thought process is going to be the same thing that you're going to do. And it all just kind of relates back to critical thinking. Number 3. A petri dish contains 2 bacteria, and they double every minute. Following the function b at t. B at t is the same thing as f at x. F at x is the same thing as y. Okay? So 2 times 2 raised to the t power. So 2 times 2 raised to the t. So this is an exponential function. How do I know it's exponential? It's t squared, or 2 to the t, excuse me. Where b is the number of bacteria, and t is the number of minutes. The graph of the population is given to the right, so I guess that would be the graph of the population that's given. At what is the value at t equals 0? So if I allow my t to be equal to 0, if I plug into my equation, I get 2 times 2, and this 2 is raised to the 0 power. What is 2 to the 0 power? 1. So I get 2 times 1, which is equal to 2. So t equals 0 means what? There's only 2 bacteria. We started with 2 bacteria, and then we started timing it. It's like, oh, look, there's 2 bacteria. Start the clock, click. So we started with 2 bacteria. What does the point 2, 8 mean in the context of the problem? What would 2, 8 mean in the context of the problem?
After 2 minutes,
What's that? I like it. After 2 minutes, we have 8 bacteria. Okay, they're moving good. Is this growth or decay? It's growth. Okay. So with this type of problem, b at t is equal to 2 times 2 to the t power. You could say, well, in hours, how many minutes?
60.
So if I went b at 60, that would be 2 times 2 raised to the 60th power. Does anyone have a calculator with them that's the bigger, fancier one? Don't go that high? So go 2 raised to 2 caret 60. I see your calculator. That work? Comes out to 240. Is there an E in there or anything? Guys, your calculator real quick. I think all those batteries are dead too. 2 raised to the 60th power. Holy cow. Alright. If you do this on your calculator, 2 raised to the 60th power like that, the calculator comes up with roughly 1.15 e to the 18th, which is times 10 to the 18th power. And if I double that, I get 2.30 times 10 to the 18th. So how many bacteria are we talking about? Yeah. Do you think bacteria could grow technically that quick? Sure. Could that mean that bacteria, you could see, you've grown up knowing that we're going to wash hands, okay? And what saddens me is you walk into the bathroom at a restaurant, and sometimes they have some sort of direction, just in case you didn't know. Step 1, get it to warm water. Step 2, lather for at least 60 seconds. Step 3, rinse. Step 4, dry with a clean towel. I know the fellas in here, this is what our towel is. Okay. They're clean. Right? You ladies might not do that, but just realize us guys, our jeans become a towel. I mean, think about it. That is an enormous number. I mean, if you talk about this number in the context, 1, 2, 3. That's how many bacteria we have in this model after an hour. Okay? Million, billion, trillion. Yeah, I don't even know the terms. I mean, I guess I could say million, trillion, billion, trillion. So 2 billion trillion. What is it? Quintillion. So 2 quintillion. Good Latin roots. Good stuff. All right. Huh. Question for you. Is the population of the planet growing at a linear rate, a quadratic rate, or an exponential rate? Exponential. Okay? Are there certain times and eras in our life where we had some people that lost their lives? Sure. But has it really interfered with how quickly the rate is going? Not really. I mean, we're 7 billion people. That's a lot of people. What's that? Maybe. Last question. The height. Looking for a page. Oh yeah. It's the last one in the house. The heights in feet above the ground of a ball thrown into the air from the top of a building is given by, oh, I can't see that problem. Where? Is there anything there? Is it cut off?
Yeah.
-16.
It goes down to the next
Or
one.
Yeah, it does.
so t minus
Just like
10.
Okay, so you, what is the rest of it?
T minus 2 squared plus 2.
Jeez.
T minus 2 squared
T squared plus 260.
plus 2.
260.
All right, the area and feet of blah 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 top building is given by that function. Shh. What does the rest of it say?
We should calculate the graph HT sketch.
Okay, so there's definitely things. Which form is this? This in? Hey, how you doing? Yep, he's good. Thanks, man. This is which form is this? Is this in standard form, vertex form? It's in vertex form. So what's the vertex?
264.
2,264. So this is represented t in seconds. You're tossing an object. So after you've tossed this object, once it has been airborne for 2 seconds beyond after you've thrown it, it's at 264 feet above the ground. What else does that problem say?
What is the y-intercept of the graph?
What is the y-intercept of the graph? Ooh, how do we find the y-intercept of the graph? So I got to multiply this out. I got to do this. T minus 2, T minus 2. Do you agree with that so far?
Yeah.
Plus 264. So I need to multiply this out. So I have 16, and that's t squared minus 2t minus 2t, which is minus 4t, plus 4, plus 264. Still with me? Let's distribute the negative 16. So I get negative 16 t squared plus 64t minus 64 plus 264. So I'm going to combine those, right? Oh, there's a T right there. Yes. What is our y-intercept in this problem?
200.
200. What does that mean in the context of the problem? What does that 200 mean? Where you threw it from. So you threw this particular object up into the air, but you had already been 200 feet off the ground for whatever reason. You could have been on top of a building, or you're 200 feet tall, or you jumped really, really high and then threw it. Okay? So is your maximum height different than the where you started throwing it from? Yeah, so did you throw the ball upward then? Yeah. If you had thrown the ball downward, your maximum height would have been where you were standing from. Does that make sense? So you're like trying to launch this upward into the air versus throwing it straight down. So the problem itself has an awful lot of context. Is there anything else that problem says to do on there?
What is the highest point?
The highest point, 264 feet. We know that because that's the vertex.
At what time was the ball?
At what time? At 2 seconds after I threw the ball. What else do we know?
What would be a reasonable domain for this problem?
A reasonable domain for this problem. That's a great question. Do we have negative seconds that are going to take place?
No.
No? So I would say the domain would be from 0, okay, because that's you hadn't thrown the ball yet, until the point it hit the ground. So maybe, I don't know, did anyone graph this? If you graphed it, do you see where it crossed the? I'll bring up my graphing calculator just for fun. can either graph the blue or the green. Both answers are going to be the same, so I'll just graph the green. Negative 16 squared. Yes, you missed. I didn't hear you.
I saw the lights
Hey, so if I hit graph, why can I not see my graph yet? Yeah. So with this, if you went to zoom, and then perhaps if you went to zoom fit, this might allow us to see. So this point right here, this is the point 0, 200. I toss that ball. It goes up, and then it's on its way back down. So 1, 2, 3, 4, 5, 6. So a reasonable domain for this might be from 0 to 10, even though 10 is going to be down here. This would mean the ball is underground now. I don't need to worry about this portion of the parabola. It's non-existent to me. So that's what our problem is shown in the context of this. Okay? Our vertex is here. We can easily find that. We already know what it is. Did I answer all the questions on that?
Yeah.
You know, I know most of you are going to cry yourselves to sleep knowing this, but we just did our homework for tonight.
Oh, dang it.